My name is Cindy, and as Andrea said, you probably best know me from Twitter or from my blog. A couple days ago, probably was the last week of 2017, I wrote this blog post called Testing Microservices the Sane Way. It was a 40-minute blog post, and I am still astounded how many people read it. I mean, because I personally do not read anything that's longer than 10 minutes. I mean, I can write stuff that's 40 minutes or 60 minutes long, but I can't read. I mean, my attention span is like 10 minutes, right? So kudos to everyone who's read this. So like I said, my name is Cindy. You probably know me on Twitter and pretty much everywhere on the internet as Copy Construct, and I'm here to talk about microservices. So the main reason why I wrote this blog post was because I read another blog post about someone who described their testing infrastructure. It was the blog post of a company, which is probably large-ish, but we're not talking about Google or like Facebook or anything, but pretty large-ish for a San Francisco company. And I sort of read the whole blog post, and they were talking about they have this pretty cool infrastructure where they had like Mesos that was like scheduling Jenkins and EC2. And it had it was doing bin packing, it was running 1 million tests, it was like, what else did it do? Let's see. It was like streaming all the logs to Kafka and then sending all to S3. It was like this incredibly complex system that people had built. And basically the whole blog post was about how it just greatly helped their developers to run millions of tests in a very sort of like fast way, right? Which is probably always seen as a positive thing. When I finished reading that, my sort of reaction was like, oh my God, why is this so complex? And why is it that this industry thinks of testing as this thing that needs to, just necessarily be done this way, where it's just like, you have a system which is probably even more complex than your actual production system that you spin up just to run a bunch of tests, right? So, once I read that, I was like, oh my God. I mean, I was just completely surprised. I was just pretty unsettled. I was like, why are we doing this? And because this is not just one company, right? Pretty much everyone attempts to do this or get somewhere close to this, and bigger companies like Google probably have something like that's orders of magnitude even more complex than this. But at least from my personal experience, trying to build these kind of systems, at least the way I see it, it's not really the right way to really be testing microservices. So it really started with this conversation that I was having on Twitter. I asked someone, okay, so what is the best way in which you test microservices? I think the initial conversation was, how do you test service mesh architectures? Because that is like a strong area of interest of mine. So when I was asking people that, I got a lot of answers, but I got this one reply from someone called David who mentioned that I believe he works at Amazon, that's what his Twitter bio says, that increasingly convinced that integration testing at scale in a microservices environment is untenable. And this also completely matches with my own experience, as well as what I strongly believe. The whole point of microservices is to enable individual teams to build things separately, to ship things separately, right? And to deploy things separately, so that you have this self-contained system with a bounded context that really encapsulate a certain amount of business functionality. Yet when it comes to testing these things, we test it all together, right? The default is that we need these incredibly complex systems just to integration test all these things before we can deploy something. So before we even get to testing, another thing that I've seen people do, and this is also something that I've seen happen at one of the previous companies that I worked at, is not just testing microservices, but even when it comes to developing microservices, what a lot of people do is they try to replicate the entire topology on developer laptops, right? So, 4 or 5 years ago, I tried, the company that I was working at, we tried to do this with Vagrant. The whole idea was like, with a single Vagrant up, you should be able to boot the entire cloud up on a laptop, right? These days, pretty much everyone's doing Docker Compose. So the thing is, in my opinion, this is really the wrong mindset. Not only is it not scalable, and not only is it completely, it's absolutely nothing like a cloud environment, right? It's also really the wrong mindset to be thinking about it. When I had this blog post reviewed by someone called Fred Heber, one of the things that he pointed out was that really trying to boot a cloud on your laptop is almost like you're supporting the worst possible cloud provider ever. That's like a single laptop, right? Because that's kind of what you're trying to replicate when you try to boot all of, say, a dozen microservices in a laptop. That sort of becomes the worst possible cloud ever. Even your actual cloud is going to be far more effective than that. So why are we even doing this? It's because people, even when we build microservices, we are really building distributed monolithic applications, right? This is kind of what we're doing. The whole idea that we need, if we cannot decouple these different sort of boundaries when we're developing and when we're testing, then we cannot expect that when we're running these things together, that the sort of decoupling that we're trying to sort of achieve will actually work, because from the ground up we're doing it wrong. So how do we do it right? Because so if I'm saying, okay, this is all wrong, so what is the right way to do it? Well, couple caveats. My background is startups, really early stage startups. We're not even talking about like the unicorns. We're talking about companies that are small and scrappy and almost always resource constrained, where we've always had to make smart bets and smart choices, and where we've always had to do a lot with a little. And what that means is that we've never always had the resources to just go out and do what some of these companies who blog about some of these things do, right? And what we've always had to do is think about the opportunity cost, the maintenance cost, as well as what the trade-offs and the payoffs are before we make any sort of decision. And this also applies to testing. So, I was just drawing this out when I was writing this blog post about just the taxonomy of testing, right? How do we really think of testing? And for a lot of people, the way especially a lot of software engineers think of testing is that you write a bunch of automated tests. And pre-production testing is like the only thing that they really sort of focus on. And even then, you don't focus on all of this. It's primarily just writing automated tests, writing tests in the form of code, right? And one of the reasons I even sort of like created this illustration is because we really have to see testing as a spectrum, not as this thing that you do when you write code. It's this thing that you run every time you create a branch, the thing that you sort of like need this thing to go green before you merge and deploy. But it needs to be seen as a spectrum that really starts when you start writing code, and it doesn't really end until you have sort of like decommissioned that code from production, right? It's just something that's it's continuous. It's a continuum, and it's not this sort of thing that you just do. And back in the day, you probably had testers, right? You had QA engineers and like software engineers in tests. I'm guessing bigger companies still have this, where the developer writes the code and the engineers in test actually write the tests. And then, if it was a service, you hand it over to someone in operations to actually run it. But, this is not the sort of like, I've never done this at any company that I've worked at. I've always been the person writing the tests, deploying the code, monitoring, and also sort of like rolling back and firefighting, right? Now, I agree that this is unusual, and this probably doesn't apply to everyone, but that is the position from which, a lot of my opinions are sort of like formed, right? So when I think of it that way, I personally find this model to be incredibly powerful, because for the first time ever, it allows us to think about testing in a very holistic manner. It allows us to think about testing, across the breadth of it, and not just this little type of silos. So one of the reasons I even created this was because I sort of like I primarily see all of these sort of like mechanisms, all of these techniques as a form of testing, right? And this is again the distinction isn't quite as binary. Like you could probably be doing some sort of A/B testing in a test environment. You could probably do profiling in production. So this is a very fluid sort of border here. But this is how I see testing. And I don't think anyone here, at least anyone that I know of, does all forms of testing. But really, the goal is to really pick the subset of testing techniques that we need given our application's requirements, right? For really safety-critical and health-critical systems, for systems that deal with money, probably the vast majority of testing is going to be done pre-production. But I personally only have experience running services, running back-end services, and running services whose deployment I control, which means that if something goes bad, I can immediately sort of roll back, right? And that is super powerful, and that is not something that a lot of people actually enjoy, because if you're shipping a desktop application, you ship it to people, and if you ship it with a bug, then unless they all sort of upgrade or sort of like change their thing, it's not going to change, right? But if you're just deploying a service and you're controlling the deployment, you can ship something, and if it's not great, you can roll back, right? So when you think of testing services, I kind of think, at least from my perspective, I tend to give, I tend to put testing in production a lot higher in the sort of like priority list than I necessarily do pre-production testing. So the other sort of thing that I've been thinking about was this thread by Jeremiah, where she actually said that, she was responding to someone else who was saying that, there's probably a lot of code that you don't necessarily have to test, that you can just deploy, right? And this was pretty controversial when it sort of came out, because a whole bunch of people were like, don't ever do this, right? And the reason why I kind of felt that there was this reaction to what she was saying was because a lot of software engineers, what we're taught, at our mother's knees is that testing is a good thing. We have to be testing. And if you don't test, then if you don't write, like, when I mean test, like a very narrow definition of test, then, you're doing it wrong, right? Which means that when people find it really hard to even accept that automated pre-production testing can actually sometimes be insufficient, to the point where it can be sometimes entirely useless. And I think that really was the reason why there was this huge uproar to what Sarah was saying, which was that people are stuck in a different mindset. And for us to really sort of embrace this more holistic form of testing, it really becomes important to just start thinking about it differently. And what I mean thinking about it differently is that I think reliability is not an SRE concern. I personally see it as a software engineering concern, right? I mean, I don't personally think that the code that I write is going to be made any more reliable by hiring an SRE team. I think that this whole top-down approach where, you have like certain people writing the code and certain people sort of like make it reliable, I don't think that works. And I really think reliability is a feature of software, right? Like testing, it's like something that you build into the code that you write so that then you can understand what it's doing in a lot better way. And understanding what it's doing is also a form of testing because we're just seeing, do our assumptions hold good? Did everything that we sort of like base our system on, does that all still hold water, right? So this is, again, something that I very strongly believe in, that to be able to sort of push certain amounts of regression testing to post-production monitoring requires not just a change in, a mindset, and a certain appetite for risk, obviously, but it really requires software engineers to code for failure, right? And I think that is the thing that I'm not seeing enough. And to be honest, I don't do it enough, right? I mean, this is like, I'm not saying that I'm doing everything perfectly. I probably don't do this well enough. And that's probably something that I would like to see, not just me, but also in general the industry, just do better. Because it involves a whole different mindset. It really involves like thinking from the ground up how we build software. And again, this is probably true for all kinds of software, but this is especially true for microservices, right? Because what this crazy service-oriented architectures that we're building, what they really connote is this incredibly complex system that's always going to exist in some form of unhealthiness, right? It's almost like saying unhealthy is the new healthy, because we have like all of these crazy mechanisms like retries and circuit breaking and multi-tiered caching and eventual consistency and all these relaxed guarantees just to make sure that our service is going to be sort of healthy. So we're by default in a mode where we are thinking in a way where unhealthy is really the norm. But when we test as if healthy is the norm, right? Which is kind of like really bizarre when you think about it. So again, something that Fred Heber said, which was that when you have a large-scale system, if your tests require 100% health, then you've got a problem because you're not really testing the system. You're not even testing what you're building for, but you're really testing something totally different, which is like the success case. What you're actually doing is architecting for failure. And that's completely bizarre to me, right? So code accordingly, right? This was another tweet that I saw, and I think I retweeted this. Failure is going to happen. It may not be even something you did. It's probably something cloud provider did. The reason it's not deployment, the reason internet, code accordingly. So I see a lot of these, and whenever I see tweets like this, my initial instinct is like, hell yeah, this is so true. My second instinct is like, fuck no, this is not true. What is this person even talking about? This is like so hand-wavy, and this is like so, like, yeah, code accordingly. Like, what am I supposed to do? Like, I used to ask these questions like a couple of years ago. It's like, what the hell am I supposed to do? Like, give me answers. Don't just give me these little like thought leadery like sound bites that then gets fucking tweeted 100 times. Like what am I supposed to be doing? Like, code accordingly. Right? I mean, I'm ranting here, but I mean, this is what I personally feel. So, well, the more I think about it, there's some certain things that I feel software engineers can really do. Really try to understand when they're actually coding in order to code accordingly. So what does that mean? Well, in my opinion, it comes down to three things. It really comes down to coding for debugging, being able to instrument your services well enough so that you can really, so that when you're actually debugging something, you're not really starting with a conjecture, and you're not really starting with this hypothesis, but you can ask questions of your system that you can ask questions, and then you can sort of like refine your hypotheses based on this question. Keep asking questions until you come to something which is probably actually really true to the root cause, rather than sort of like looking at the wrong things, or like just, you know, trying to sort of like fit this failure into this mental model that you already have built based on like, because you build the software, so you have this mental model of how it should work, then something is failing, and then you try to retrofit that to this mental model that you have, which in my opinion is completely the wrong way to do it. So number one, instrument your services better. Number two, understand the operational semantics of the application. How is it deployed? You know, how is a process started on a new host? Like, because if you think of a lot of outages, they're actually like deployment outages. It's basically bad code getting deployed for some reason, right? And again, a lot of these code gets deployed after going through like this huge, like intricate sort of like testing pipelines. Then why is it still the case that deployments are like the number one cause of outages, or like bad deploys are the number one cause of like, you know, services going down, right? It's again because when you're coding and also when you're testing, what you're really validating is your flawed mental model, not really the reality, right? I mean, does anyone disagree with that? No? Okay, cool, because that's what I strongly believe, is that you still have these outages despite doing everything correctly. And that's because what you're really testing is not the reality, but what you're testing is just your bias, right? It's just this big form of confirmation bias. That's what you're really dealing with. So, you know, just being able to understand the operational semantics, I personally feel, allows us to think about how services fail in a better way. Which means, okay, so what process manager are you using? Like, what's the restart mechanism? How many times is it going to try to restart? What's your deployment mechanism? Is it like some sort of like blue-green deploy, or like doing some sort of like red-black deploy, or doing this rolling deploys? Like, you know, like what is the release engineering sort of like practices that are being used? And, you know, how does that lead to failure? And there's one more in my opinion, and that really comes down to the operational semantics of the dependencies we use, right? We build on top of crazy amount of dependencies. That's, I mean, in my opinion, at least what I've mostly been doing is gluing together a bunch of dependencies. Basically, it's JSON or some libraries on top of this, and then you have like hugely sort of like tower of abstraction on top of which we build our little tiny abstractions, right? And the best way to deal with abstractions is, at least in my opinion, even the leakiest ones, is to sort of like have some amount of trust that it's going to say what it says on the tin, right? I mean, it's not ideal, but if you're just going to like start doubting every single abstraction layer that we're dealing with, right down to, I don't know, TCP or even like your ARP packets or something, then we're probably never going to get anything shipped, right? So the best way we deal with abstractions is sort of like having a certain level of trust in the abstraction. But failure still happens, and in my opinion, that happens because we don't fully understand the boundaries between the abstractions well enough. And spending a little more time there, I personally feel, has sort of like helped me understand the services and the systems that I build better. So what do I mean by that? Well, you know, a good example would be if you're using a service like Console for service discovery, right? It has a certain sort of like default consistency modes in which it sort of like queries for like, you know, other services. That, in the default case, is strongly consistent. This is probably not what you might need for when you are trying to do service discovery, because that is more of an eventually consistent problem, right? Which means that the developer actually using a console library, or if someone provides console as a service, they need to set the right same defaults. And different people who are using this library need to understand these defaults and be able to sort of like reason about whether that is the right default for their needs, right? So just spending some time in understanding a lot of these operational semantics of both the dependencies as well as the application and programming for debuggability is, in my opinion, what I think connotes coding accordingly, or rather coding for failure. Another point Sarah made was that, you know, the writing and running of tests itself is like not a goal in itself. Like, tests themselves pretty much are, I wouldn't say useless, but like in and of themselves, they're not like particularly useful. And the reason is, you know, again, I stated this previously, it's just a big form of confirmation bias, all the tests that we write, because we're sort of like predicting beforehand what are all the failures and success modes. And tests are only good as their ability to predict, right? And the reason why systems fail is because we're not able to predict that failure, or we didn't try to understand that well enough, right? So what this means, in my opinion, is that just having more tests doesn't make your service any better. It just means that you can think of more cases, but there's probably still a case that's going to take your service down. And if you don't understand that, then, you know, having like a million tests doesn't help you in any way, right? So, and when we talk about tests, the other thing that really annoys me is this test pyramid. So this was probably proposed back in like, I don't know, the early 2000s, along with the whole like agile movement and everything. I was probably really small then, so I don't really understand or like know like the history of this. But like every single testing blog post or like every single like testing conversation people have, like this thing gets wheeled out. And every time I look at this, I'm like, okay, yeah, if you have like a Rails app or like have a, like this single Django app that you want to do something with, you have a CRUD app basically, yeah, this kind of makes sense, right? But when it comes to really dealing with this kind of service, like, is this the best we can do when it comes to testing? Seriously? Like, why do we still talk about this thing, right? This is, in my opinion, super old, and this is completely the wrong way to think about testing this kind of a service-oriented architecture. This is completely hypothetical, by the way. But it's not very far removed from some of the sort of topologies that I've personally worked with. So, in my opinion, I'm totally wearing my thought leader hat now. This is what testing should look like. And I see it more as well, it's not a pyramid, it's more like a funnel. I don't know why I made it a funnel. It could have probably been this big rectangle, but for some reason, this is a funnel. And in my opinion, to really test these kind of crazy architectures, we need to think of testing as a spectrum. And it just doesn't end when you write some code. It just doesn't end when you deploy something. It's this large, wide spectrum where it sort of continues until you really decommission your applications, right? Again, this isn't sort of comprehensive by any way, but this is sort of my mental model for testing this kind of system. You have your unit tests, you have your benchmarking, you have your property-based testing, you have your contract testing. All this is kind of like things that you can do in development, right? And you can do all of this without necessarily spinning up this whole crazy topology locally. You can just like run one service and still have all of these kinds of tests. Testing pre-production, and personally, I believe that massive integration tests are an anti-pattern. I mean, because think of it, what we're really trying to do when people try to like build this whole dev environment, then an identical test environment, rather try to keep your test environment as close as possible to production is, it's not really the real thing, because it becomes this huge maintenance burden. And especially for smaller companies, we just can't do it. It's just not tenable. It's like, probably it ends up requiring a team in its own right to just maintain, right? And that's kind of hard. And the fact is, doing all of that doesn't give you any more confidence in your system. So if you're going to be integration testing a microservice architecture, then you should be able to test that against production. And this all has also the added benefit in that it helps you really think about your boundaries. It makes you certain that if you should be able to test a potentially buggy sort of like service in production with the rest of them, then it really forces you to think of what the boundary should be and how the blast radius, how widespread the blast radius might be. And the goal is that it should be really small, in that even if you push out this really shitty sort of like patch, or like, you sort of like push out this big buggy feature, it really shouldn't take down the rest of your service, right? And if you actually think about it, that's really what the whole the goal of microservices architectures are, in that, you have like these standalone services that do this one thing well. They don't really affect or really, greatly affect like all the other services. So this is like a very positive architectural pressure in my mind, being able to integration test your single service with your production environment. Then there's config tests, and this is again something that I've learned from just my operations colleagues, in that configuration changes can sometimes be more dangerous than any code change, right? Especially when it comes to things like Nginx configs, or even HAProxy configs, or even some sort of like, given that we live in the era of service meshes like Envoy or Linkerd, all these, if you think about service meshes, it's like, it becomes this huge single point of failure across like your entire fleet, because it sits in between every damn service that you have. And if you're not going to be testing the config changes before pushing out a change to Envoy, it's not just going to take down one service, it has the potential to take down your entire architecture. That's pretty scary to me. And I'm surprised that more people don't talk about like, how to build resilience in your service mesh. That's something that I'm hoping will happen in the next year or two as like this whole paradigm gains more traction. Then there's shadowing, which is take a certain amount of your production traffic and actually replay it against test, right? But I'm also arguing that let's not have this whole crazy test cluster in place, which means that integration testing and shadowing sort of like combine together. Because when integration testing with production, don't sort of like generate your own load, or don't try to sort of like create like your own request response cycle, but try to use something from production that's just happened like maybe 5 seconds ago, because that's as real as you can get. And then there's testing in production, obviously. There's A/B testing, feature flagging, canarying, distributor tracing, monitoring. I think monitoring is a form of testing. And that's, again, why I think software engineers should be doing it. It's not an operational concern. And just understanding what your software is doing in production, right? Because you could build something, but it is completely constrained by all the biases that you have and your mental models and basically how your team thinks about it. And a lot of reasons, if you think of a lot of, I guess, failed projects, are just like big architectural flaws. It's primarily because people didn't validate soon enough in production. And it's probably because people let their biases carry them too far until they spend too many engineering cycles and too much time building something that's pretty big, but then it's probably too flawed because you didn't iterate rapidly and you didn't basically get feedback from production fast enough. But this is like a service that I've been sort of like the developer for, or on call for the better part of the last 2 years. It doesn't matter what each service really does, but when I develop this thing, I don't necessarily bring up all these services on my laptop. What I really do is just bring up this one thing and then test the rest in production. And surprisingly, it's worked well enough for us. I mean, there's never been an outage because I've been developing this way. And the other pretty weird thing is, I've worked at companies where people would come and ask us, like, can you give us your whole service as a Docker container? When you're talking about like a SaaS service, like, can you just give it your service as a Docker container so that we can integration test our services with basically yours? Because most of us, these days just integrate with a whole bunch of third-party services, as we should, because if it's not your core competency, if you're a startup, then you should be probably outsourcing it to someone else, right? Whose basic business model and whose basically the reason they even exist is because they're providing the service. And then it begs the question, how do you even test these services, right? And in my opinion, the way you test is not by asking them to give you a Docker container that then you sort of like spin up in your test environment. You need to either have better abstractions in place that, where you can sort of like understand your vendor's failure modes, sort of program against that, or you just directly, talk to directly make like a network call to this third-party service that you're talking to, which again becomes harder because a lot of services don't really provide, a test mode sort of like features, or they don't really allow you to test it. It's like every time you make a call to them, you get charged, which is kind of sucks. But that's a user experience thing, right? And in my opinion, not a lot of vendors do this thing where they really think about how someone who's going to be integrating with them are going to test well, right? So yeah, that's pretty much all I got. And a lot of these thoughts are like probably better explained and better articulated in the blog post. If anyone really wants to spend 40 minutes reading that, go read that. I won't do that. But yeah, thank you.